Okay, so I'm going to go through the solutions to the test. The same number can be represented in different ways. Write two or more representations of each of the numbers in the table below by choosing only from the following list. Note, some of the representations may be approximations. So maybe approximations means that they are rounded. Okay, so 6 to the minus 2. So I'm going to get my calculator and I'm going to type that in. So 6 to the power of minus 2 is 1 over 36. And then I'm just going to press SD and get that as a decimal. So as a decimal, it's 0.027 recurring. Right, so now I'm looking up here. Like it's obviously not, it's not going to be this one or this one or this one because I know it's 1 over 36, so it's not going to be any of them. 9% is 9 over 100, so that's just 0.09, so it's not that one. I'm going to check root 3 to the power of 4. That's 9, so that's not it. 2 to the 4 times 2 to the 5. That one is 512, so that's not it. 0.25, this one here, is 1048576. 2.8% is 2.8 divided by 100. So 2.8 divided by 100. Oh. So that's 0.028. And this over here is 0.02777777. So if you rounded it, it would be 0.028. So that's one of them. Okay, that makes sense. So that is, yeah, does that make sense? Like, as in if I use that recurring dot, or if you press SD again in your calculator, you get like a load of sevens. And then if I round that, stop here, this 7 is big enough to push up the previous 7. So I would get 0.028 if I rounded it, and that's what this is. So that works. 36% is 36 over 100. That's 0.36. 900% is 900 over 100, which is 9 again. Oh, look, 0.027 recurring. That's literally there. Can't believe I didn't see that. Right, so that's those two. 81 to the power of a half. So again, into my calculator, 81 power a half. That's 9. And I actually had them already there and there. So they're done. So the square root of 3 to the power of 4 and 900%. What's that? 2 to the power of 20. Okay, so I'm typing that in. Oh, that's the one I got. Okay, so it's 1048576, which I got up there. So that is 0.25 to the power of minus 10. This one here, I actually think that could be it. 1.05 by 10 to the power of 6. Yeah. This one is 105 and then 4 zeros. And if we rounded this so that it stopped there, is the 8 big enough to push up the 4? Yes, it is. So it's 105 and then fill it out with zeros. So that's the same thing. So 1.05 by 10 to the 6. So let's have a look at the marking scheme for that one. So 10 marks for that one, and you can see there's a low partial and a high partial for attempt marks, but 10. Right, the next one is given the number line below, give the number line below an appropriate scale and then mark the numbers on it. Okay. So, sorry, I'm just going to write what these numbers are because I can't plot them if they're not decimals, so I'm just going to get them as decimals. So the square root of 82 is 9.1. I don't know if I might need to go further. It's 9.055385138. So that's the number. I'm going with 9.1, as in I'm doing one decimal place. 3 pi. 3 shift pi change. 3 shift pi equals change. So 3 pi is 9.4 and the full number is 424961. Okay, the next one is a decimal, 8.9. The one after is a decimal, it's 9. 37 over 4. So it's 9.3, and what it actually is 9.25. I'm just going with one decimal place. And then this one, 9.3 by 10 to the 0. Oh, see, is that just 9.3? 9.3 by 10 to the power of 0. 9.3 by 10 to the power of 0. Yeah, that's 9.3. Okay, so I don't want to put the two of them in the same place. For this one, I'm going to go with 9.25. Right, so the biggest one is 9.4 and the smallest one is 8.9. Okay, so we'll make 8.9 our start and spread it out. So I'm going to go 3 boxes. 9, 9.1, 9.2, 9.3, and 9.4. Okay, and then just pop them on. So 8.9 is just 8.9. 9 is just 9. 9.1 is the square root of 82. 9.25 is right in the middle, and it's 37 over 4. 9.3 is that 9.3 by 10 to the 0. And 9.4 is 3 pi. Is that right? 1, 2, 3, 4, 5, 6. So you had to choose a scale. So I went up in boxes of 3 for 0.1s, and then you had to put those numbers onto the scale. 15 marks for that, and again you have 10 marks. Okay, so that means the first one should be worth 25, and it is. Okay, so this one, a bit of an indices question. So 6, we want to write 6 to the power of minus 2 without indices. So I just typed that into my calculator and it's 1 over 36. And 81 to the power of a half is, power of a half is the same as the square root, and that gives you 9. 2 to the 24 in scientific notation. I think your calculator would probably just do this for you. Oh no, it doesn't. So 2 to the 24 is 167777216. Now, they want 3 significant figures. Okay, we'll get to that in a second. So the first thing is I need to put my decimal point. I'm just going to give myself a little bit of space. I want to put my decimal point in there. Yeah, so at the moment it's here and I want to put it into the number. Okay, so we do 1.67777216. We always have multiply 10, and then you're just counting. So 1, 2, 3, 4, 5, 6, 7. Yeah, counting in between the dots. And then the last thing over here is the 3 significant figures. So this is my first significant figure. Because remember, significant figures are not decimal places. They start at the beginning. So significant figures 1, 2, 3. And then I'm going to stop. I look at the number after, which is a 7. Is that strong enough to push the previous one up? It is. So it's 1.68. Then we drop the rest of the number by 10 to the 7. And that's that one. Right, so... Oh. Question 2 appears to be missing. Okay. Don't worry about that for the time being. What was it worth? 15? No, it's worth 25 again. Okay. There definitely is a scheme for that online, so I will find it now in 1 second. I'll just finish it and then I'll find it. Okay, so this one, you can't use your calculator. That's what they're trying to do. They're trying to make sure you can't use your calculator. So this is tricky. So in the bracket, we have an A that has no power, which means it has an invisible power of 1. And then we have an A with a root on it, and the square root becomes a half. Yeah? That's all in a bracket with a little 3, and then I have A to the 4. This here, so this here is law 1, where if you are multiplying two numbers with the same base, you add the powers. So if you add 1.5, you get 1.5. Maybe we do it as a decimal. So you get 1.5. And then that's to the power of 3. And that's over A to the power of 4. And then in here, I'm pretty sure it's law 3, where you have power to a power. And when you have power to a power, you multiply. So 3 multiplied by 1.5 is 4.5. Yeah, getting there. This then is law 2, where when you have a division, you subtract. So that gives us A to the power of 0.5. Or another way of saying it is A to the power of a half. And then remember from the beginning, that the power of a half is a root. Sorry. So that's the square root of A, which is what we wanted. All right, and then the last one is the ones where you have to solve. So we need them to match. So I'm going to change this to 7 to the power of 2, because 49 is 7 to the power of 2. Then I have an x on the outside, I have a 7, and I have a 2 plus x. The only thing I changed there was 49 into 7 squared. Here we have power inside, power outside, so I can multiply. So that is 7, and 2 times x is 2x, and that equals 7 to the 2 plus x. So if these are to be equal, which it says they are, then this must be the same as this. Now, this is specifically tricky, as in multiplication and addition is hard. So it's 2x equals 2 plus x. And we need to gather the x's. So we minus an x from here and we minus an x from here. There's an invisible 1 on that x. So 2x minus 1x is 1x equals 2. And then we're trying to get the x on its own. So we divide by 1, divide by 1. So x equals 2. And then this bit, and I'm not going to be too fussy about this, but I may as well answer it correctly while I'm doing it. Verify your answer basically means check your answer, which is where we just go back to the very beginning. So 49 to the x equals 7 to the 2 plus x. And we put in our answer and see does it work. So we said that x is 2, so I'm going to replace that with a 2. And we said that x was 2, so I'm going to replace that with a 2. So according to me, 49 to the power of 2 should be the same as 7 to the power of 4. Okay, so 49 to the power of 2, my calculator says is 2401. And 7 to the power of 4 is 2401. So it works. Now, how am I going to... I'll keep going. I'll figure it out in a second how I'm going to get the marking scheme for that. Anyway, this was the trapezoidal row. We did this in class last week. Okay, so this is where you do the width of the bar, which is 3, always over 2. Then you do first, which is 4. Actually, I might do a bit of colour here. So the first is 4, plus the last, which is 8, and then plus twice, and the rest are, you just add them all up. So I'm actually just going to do this. So I'm going to add 5.8 plus 7 plus 6.5 plus 6 plus 4.8 plus 6 plus 6.5. So I'm getting, when I add up the rest, I'm getting 42.6. Now, because I'm not writing that out, I'm just going to double check I have it right. So 5.8 plus 7 plus 6.5 plus 6 plus 4.8 plus 6 plus 6.5. Yeah, 42.6. Okay, and then I'm just going to do that. So 3 over 2 brackets, 4 plus 8 plus 2 bracket 42.6. I'm going to close, this bracket, and then I'm going to close the original bracket. So on the calculator, they don't look different. They're just the same. So I'm getting 145.8. Now, hopefully that is in here. I might have the wrong draft of the scheme, maybe. Maybe that's what it is, actually, that I have the wrong draft. Anyway, 145.8 is right. And that's worth 10 marks. So does that tally? Let's have a look. 10, yeah, 10 marks for question 3. Okay. Right. So this one. The top of a particular lighthouse is in the shape of a hemisphere on top of a cylinder. The hemisphere and the cylinder both have a radius of 3 meters. Okay. Sorry, now I'm going to get, so hemisphere and cylinder. So if I go out here, go into my formula and tables book. God, So hemisphere is there. And then Matt's cylinder is the one at the top there. Okay, just so I have them. So find the volume of the hemisphere, right? So there isn't a hemisphere, there's only a sphere, but that's okay. Because I know just half it, and they want the volume. Yeah? So it's the volume, so it's this one here. So I'm going to bring this over. Oh, it doesn't need to be that big. Yeah? So that's what I'm after taking, but I need to note that that's a sphere. Okay. Oh, even that's a bit... Okay, anyway, we'll keep going. So it's 4/3. It says in terms of pi, so I won't sub in for pi. And then it says radius, and the radius is 3, and the formula says to cube it. So that's it. 4/3 pi 3 cubed. So 36 pi is what I'm getting there. Check the scheme. Sorry, I